Hello EP Calculus students, this is Mr. McAllen, and today I'm doing a recap video of what we did in class, as well as some of the things we may not have done in class. So the first thing that we started off talking about was if you were given a function, say the function is f of x is equal to x cubed, we can find the average rate of change on any interval we choose. So let's say that in this example, it says the function is x cubed and find the average rate of change on the interval from, let's say, 2 to 3. So what you would need to do is use average rate of change as slope. So you would say, if in terms of a picture, x cubed would look like this, and 2 would be here, so that would be an 8 value, and 3 would be here, and that would be a 27 value. The average rate of change would be the change in y over the change in x, which would be 27 minus 8 over a width of 1. So the average rate of change would be it would be 3 minus 2, which would be 1. So this would be 19 over 1 would be the average rate of change. So in calculus, we want to find out the instantaneous rate of change. So what we do is we convert this notation to a function-based formula, which is pretty simple, but the definition was that we used today in class was f of a plus h minus f of a all over h. Well, it's not really all over h, it's all over a plus h minus a, which when that simplifies, you would do the limit as h goes to 0, f of a plus h minus f of a all over h. This is the definition for the slope of the tangent line at a point. What's happening is the interval from 2 to 3 is shrinking to 0 by putting this limit on the difference quotient. So let's try to do the average rate of change, so find, for our second example, find the instantaneous rate of change for f of x is equal to x cubed at, let's say, x equals a. So we're going to apply this definition of the definition of the difference quotient. We're going to say m of the tangent line will equal the limit as h goes to 0 of f of a plus h minus f of a all over h. Now this is where I have to be careful. I need to plug in to this function a plus h. So a plus h quantity cubed minus a cubed all over h. I'm going to limit h to go to 0. I have to do a little bit of algebra. I've got to cube a plus h, and that requires squaring it first. And here I'm going to FOIL that. I got a squared plus 2ah from, foiling the outer and the inner, and then doing the last. So that's a plus h squared. Now I got to multiply that by a plus h again to get a plus h cubed. So it's going to be a squared plus 2ah plus h squared times a plus h. So I'm going to FOIL this again. Well, not really FOIL, but multiply terms. So I got a cubed plus 2a squared h plus a h squared for multiplying the a by these three, plus I got to multiply these three things by h. So I've got plus a squared h plus 2ah squared plus h cubed. That is what I want to put here. So I'm going to simplify this limit. Actually, not simplify, it's going to look a lot more complicated. H goes to 0. I'm going to put in all those terms. A cubed plus, Well, I can combine this and this to have 3a squared h plus combine this and this to have 3a h squared plus h cubed minus a cubed all over h. And now when I do the limit, I just simplify this. I have 3a squared h plus 3a h squared plus h cubed all over h. I'm going to factor h out of every term. That cancels that. I'm going to limit h to 0, and I'm going to get my answer for this will be 3a squared. So the tangent line slope will be equal to 3a squared, which means this. If they said find slope of tangent line at a equals 2, now I know that when on a cubic function, when I'm at 2, the slope of that point will equal 3 times a squared, which is 3 times 2 squared, which is a 12th slope. So that would tell me my instantaneous rate of change. Okay, so in class today, we worked with this example. I'm going to do it as a recap, where they gave us a function of a hyperbola, and they want us to find the slope, the equation for the slope of the tangent line for any x value. And we're going to let that x value be x equals a. So this is again using that definition, m equals f of a plus h minus f of a all over h. So I'm going to plug in, oh remember I have to limit h to go to 0, sorry about that. So we're going to plug in a plus h into the function, and that's going to give us 1 over a plus h minus 1 over a all over h. I'm going to limit h to go to 0. Now what I do is I've got to add these fractions together. So the common denominator is going to be a times a plus h. I'm going to add this fraction to this fraction. And this is all over h. And I just have to adjust the numerators, because before the numerator is 1, but then I put an a term in the bottom. So I'm going to put an a term in the top to compensate for that denominator I created. And I'm going to put over in this one a plus h. So now remember I have to limit h to 0. So let me fix that L. So now I'm going to add these fractions together. I have a minus a plus h all over a times a plus h all over h. I'm going to limit h to go to 0. My numerator is going to simplify. It's going to become negative h, because when you add that all together, it makes negative h, all over a times a plus h, all over h. So, what cancels? The h is canceled, leaving a negative 1, and my difference quotient is still the limit as h goes to 0 of negative 1 over a times a plus h. So to answer this question, the final answer is negative 1 over a squared. What does this mean? Well, if you look at a picture of a hyperbola, it looks like this. So if a equals 1, when I plug 1 in, your slope of your tangent line is equal to negative 1 over 1. And if you look at this hyperbola, you can see that the slope could be 1 over 1. And as you change a, you now have a formula. This would be negative 1 over 2 squared, because a is now 2, which should be negative 1 over 4. And you can find all different values for the derivative, for the slope of the tangent line as you change a. So that's where the power of this equation, and I'm going back to the equation, comes from is you can use this on any function you want as long as you can do the algebra to get through it. Hopefully this video has helped you and you'll understand what to do when you see this in the homework tonight, and tomorrow in class we'll have more time to talk about it.